together. So f plus g of x will be f of x, 3x plus 1, plus g of x, which is x squared minus 2. Just combine like terms and add them together, so we get x squared plus 3x plus minus 1. And then for f minus g of x, f of x is 3x plus 1, so 3x plus 1 minus, and because it's subtraction, we'll put this in brackets, x squared minus 2, and then so we just expand that through, so we get 3x plus 1 minus x squared plus 2, which gives us negative x squared plus 3x plus 3. Okay, so we can verify this, that it is a quadratic pointing or opening down because of the negative, and that is opening down as we've drawn here, and the y-intercept is positive 3, which is what we found here. For part A, for this f plus g of x, is a parabola opening up, and the y-intercept is negative 1, which we found here. Okay, so those two expressions match what we've drawn. And we want to state the domain and range for each of the functions. Well, the domain, from what we can see, it's only basically where the points are common, where the common domain is. Or if we want to say, well, it's going to continue on forever, let's just state the general case. So the domain, because it's a parabola, the domain will be x, an element of all real numbers. Now the range, x or y is an element of all real numbers, such that, well, it's below negative 3 but above negative 4. We could plug in, this is x is negative 1 and x is negative 2, so we could put in x equals negative 1.5 or 3/2 into the x values here and calculate what the y value is. So to be more accurate, why don't we do that? Okay, so plug in 3/2 into both of these and we'll find out what that y value actually is. So we know y is going to be, my pencil would quit breaking, greater than or equal to something or other, and we'll check that in a second. So please substitute in negative 3/2 in for the x's here and calculate what the y value will be of that vertex. Okay, and please do the same thing for the domain and range for this graph. Okay, pause the video and come back in a second to check your answers. Okay, so I found that y here is negative 3.25, and negative 3.25 is going to be negative 13/4. And for the domain of this other one over here, the domain, again, because it's a parabola, a quadratic, x is an element of all real numbers, and the range, y is an element of all real numbers, such that y is less than or equal to 5 1/4, which is going to be 21/4. Okay, so here's an example where we want to use a number line approach in order to find the domain of two functions, and then by looking at the domain of the two functions, we'll see the intersection of the domains so that we can get the domain for f plus g of x and the domain of g minus f of x. Okay, so if f of x is 2x minus 5, where the domain is from negative 2 to positive 4, we can state, okay, so negative 2 is here, and positive 4 would be about there, and it's less than or equal to, so what kind of circle would that be? Okay, we'd have a closed circle because it's including. Close on both of those. And so then the domain is going to be between these two, more or less like that. And then for the domain of G, G is a parabola, 3x squared plus x minus 1, and x is an element of all real numbers such that -4 is less than or equal to x less than 3. So -4 would be around here, and 3 would be around here-ish. And we see that -4 is less than or equal to x. So what kind of circle gives us, what do we have there? Okay, so that's a solid closed circle because it's including -4. And what kind of circle would we have for less than 3? An open circle because it is not including 3. And so then we'll just from the number line between -4 and 3, and then we see that the intersection part is between -2 and 3. So the domain for the combination of functions f plus g or g minus f is going to be -2 and including -2 up to 3, but not including 3 because the domain of G does not include 3. Okay, so that would be the domain of f plus g or g minus f of x. Now when we take a look at this function sine x, we want to determine an expression for f of x times f of x. So when we do that, since f of x is sine x, then when we do f of x, f basically times f of x, then we get sine x times sine x, which is sine x squared, which is the same as sine squared x. Okay, so that will be the expression. That would be for part A. We want to graph the new function f of x times f of x. Well, in order to do that, what we need to do is we need to take all the y coordinates of f of x and multiply them together. So we see that when we have the value of 1, 1 times 1 is obviously 1, so that is going to be a common point there. 0, where we have the zeros here, 0 times 0 is going to be 0 for all of those points. And here at -1, -1 times -1 is +1, so that point is actually going to be up here for the new function. Maybe I guess I can just put squares around these to show the new function, or the coordinates of the new function. And if we were to take a look at some other points along the way, at point 5, if we multiply 0.5 by 0.5, we will obviously get 0.25, so the point is actually going to be at a quarter, which is going to be down around here. That'll be the same at this point here, it'll be at a quarter. And then for -0.5, when we multiply -0.5 times -0.5, we again get +1/4. And then for -0.5 around here again, we're going to get +1/4. Okay, so we're starting to see what the graph's going to look like. So basically, we're going to have a graph, and I'll just do a dotted graph just to kind of distinguish it. So this graph is going to be going up like this, up to 1, and then up to the other side here, and then again up to 1. Okay, so the new graph of sine squared x is going to remain positive, and we'll basically have two wavelengths, or it'll be basically a compressed graph in two wavelengths where sine x would have one wavelength. Okay, so that is part B, the graph. And the domain and range again, the domain, this is for part C, the domain, x is an element of all real numbers because it just goes on forever and ever, and the range, y is an element of all real numbers such that, well, it only goes between 0 and 1, so it's going to be 0 less than or equal to y less than or equal to 1. Okay, so that would be the domain and range for that.